This tutorial is covering electrolytes and precipitates, how to write out the reaction. If you're given it in words, you have to translate from English words to formulas, balancing the reaction, and identifying if the product is either a covalent product, an electrolyte, or a precipitate. So we're definitely going to need our solubility chart again. We've done a little bit of this before, but we're going to do a little bit more with it. I want to point out what an electrolyte is. Remember that an electrolyte is when dissolved ions, they dissolve in solution, and then that solution will conduct electricity, kind of like the electro part of the electrolyte. There are strong electrolytes and weak electrolytes. Strong electrolytes, if this is a beaker of solution that has ions in it or electrolytes in it, strong electrolytes, when hooked up the correct way to a light bulb, will cause the light bulb to shine very brightly because it will conduct the electricity. However, if you have a weak electrolyte system or solution, then it will still conduct electricity, but it will be much duller in brightness. A covalent bond, just to remind you, a covalent bond is between two nonmetals, and a lot of them are gases. Remember, the nonmetals on the periodic table are generally in this corner of the periodic table. These are nonmetals. This is the aluminum ladder that contains the metalloids. Hydrogen is not a metal, but all of the other elements on this side of the periodic table are metals. So covalent compounds will include hydrogen and any of these nonmetals bonded with each other. All right, so let's take a look. It gives you some words, sodium hydroxide, so you have to be able to convert from English to the words. Reacts with hydrogen monochloride, so hydrogen monochloride, this is a covalent compound, to produce water and sodium chloride. Now, you have to make sure that your ions, your crisscross, your oxidation numbers are all worked out. Sodium is going to be a +1 on the periodic table, his oxidation, because he's in that first column. And so he's going to be a +1. And hydroxide is a -1, which comes off of this chart as well. And so when you crisscross your +1 and your -1, you just get one of each. Hydrogen is a +1. He's in the same column with all your other alkali metals. He's not a metal, but he's there because of his behavior. So he has a +1 charge. Chlorine on the periodic table is over here. Chlorine is going to gain an electron to be like the noble, so he's going to be negative. All these will be -1s, and then -2s and -3s and so forth, because that's how many electrons they need to have a stable electron configuration. So fluorine would be a -1, -1, -1. This is -2, -2, because they're gaining electrons. So when you crisscross these, you just need one of each. Water, hopefully you know. Sodium chloride, sodium is a +1. We just determined that. Chlorine, we just talked about, is a -1, so when you crisscross, you just need one of those. So everything is balanced with regard to each compound. Now, if you look on the left, there's one sodium. On the right, there's one. On the left, there's one hydroxide. Water can be written as H and OH. This H is positive and the OH is negative. So you have an OH here and an OH here, one H here, one H here, and one chlorine. So everything balances. So now I've passed step 2 and I'm on to step 3. Identify the products as a covalent, electrolyte, or precipitate. Okay, so we're only looking at the products. So since hydrogen and oxygen are both nonmetals, this is definitely a covalent compound. Now, we want to look and see if sodium is a metal, so we're off with the covalent. We need to look and see if it's going to be an electrolyte that dissolves in solution, or is it going to be a precipitate. So let's look at our chlorine, because our chart is primarily based on the negative parts, the anions. Our chlorine, all chlorides, are typically soluble. There are some exceptions, silver, lead 2, and mercury 2, but in this case, We're with sodium, so it's soluble. Since sodium is soluble, sodium chloride, then that means it's going to be an electrolyte. So all of the ones that have the AQ at the end will be an electrolyte. So let's look at another one. Sulfuric acid, they gave you barium nitrate, barium sulfate, and nitric acid. Now I need to confirm that these are written correctly. I went ahead and wrote barium and I wrote nitrate, but I want to make sure that barium and nitrate are written correctly. So let's look at their ions and see if we've done this correctly. Barium is in the second column, so it's going to give away 2 electrons to be have a configuration like xenon. So it's in the second column, so it's going to be a +2. So we're going to put a +2 here. Nitrate is on the back of your chart. So all nitrates are soluble. We've talked about that. And it's a -1. So we're going to put a -1 here. Now to write this compound, in order for these guys to bond together, they're going to bond in such a way that all the electrons are balanced. So I'm going to need 1 barium and 2 nitrates to actually form this compound the way that it would in real life. So let's go over here. Barium is a +2. We just determined that over here. Sulfate is on our chart. It's a -2. Again, the reason we're doing these oxidation numbers is because electrons are why chemicals bond together. So we want the electrons to be stable to fulfill the octet rule. That's why chemicals bond together. All right, so barium gives 2, sulfate takes 2. To me, they look like they balance out. You could put a 2 and a 2, but we typically reduce because you don't need doubles. So this is fine. Nitric acid they give you. So let's start balancing. On the left, we have 2 hydrogens. On the right, we have 1. So let's go ahead and put 2 here, which gives us 2 nitrates because this 2 applies to everything in the compound. And we have 2 nitrates, so that works out. 1 sulfate, 1 sulfate. 1 barium, now we're balanced. So we've done that. Now we want to identify the products if they're covalent, electrolyte, or precipitate. Here's a product. All right. It's clearly got a metal in it. Barium's on the left side of the periodic table, so it's not a covalent. So let's look. Sulfates are here. Most sulfates are soluble, except, look, barium. Barium is with our sulfate, so it's an exception. So instead of being soluble, it's going to now be insoluble. So we're going to indicate that like this, which is the same as saying that it's a precipitate. So if you put sulfuric acid and barium nitrate together, you will get a solid that comes out of the solution. That solid will be barium sulfate. We know all nitrates are soluble because we've talked about that on the periodic table on this solubility chart. All nitrates are soluble, so we don't need to worry about that. And because it's soluble, it will be an electrolyte. So we will get a solid, and we will get something that electrolytes that will be in solution that will conduct electricity. So let's see if we can click through another one here. Sodium is a +1, bromine is a -1, so when you crisscross, you just need one of each. Lead 2, this 2 means it's a +2, this is oxidation number. If you look at chlorate, it's a -1, so when I have a -1 here and a 2 here, I can't put that in my compound. It's not correct to have an oxidation number along with subscripts. Now, why did I put the 2 around all of this? Is because this polyatomic counts as 1 unit. So I need 1 lead and 2 chlorates. Lead is a 2, bromine is a 1. So when you crisscross those, that's what you'll get. Sodium is a 1, and chlorate is a 1. So everything is balanced as far as that goes. Okay? All right, so now let's balance the whole reaction. I have 1 sodium here, 1 sodium here. That's nice. But I have one bromine here and 2 bromines. So to balance this, I have to put a 2 in front of this to get 2 bromines, which means that I've just messed up my sodium. So I got to go back and fix my sodium on this side. So now my sodium on the left and the right, there's 2. There are 2 bromines on the left and the right. 1 lead on the left, 1 lead on the right. 2 chlorates on the left, 2 chlorates on the right. So I'm balanced. Now let's look at our solubility real quick. Our bromine is here. Most bromines are soluble. We have a lead 2 bromide. Guess what? It's an exception. So instead of being soluble, it's going to be insoluble. So we're going to call it a precipitate because it's going to be a solid. Okay? Sodium chlorate. Here's my chlorate. All chlorates are soluble. There's no exceptions, so that's nice. So we have an aqueous solution here, and since we have an aqueous solution, we will get electrolytes. All right. Last one. Let's see if we can quickly get this done. Calcium carbonate. Calcium is 2, carbonate's 2, so they cancel. Hydrogen's 1, chlorine's 1, so they cancel. Water, carbon dioxide. Calcium is 2. Up here, chlorine is 1, so when you crisscross, you get calcium chloride this way. All right, so let's look at our products. Now, water is water, and it's not. You don't say that it's aqueous because that would mean that it dissolves in itself. So water doesn't dissolve in itself. That doesn't make any sense. So we have a covalent bond because there's 2 nonmetals. Again, there's another covalent bond here because these are nonmetals. Carbon is a nonmetal and oxygen's a nonmetal. So those are 2 covalents. Here we actually have a metal bonded with a nonmetal. I know it seems weird that calcium is a metal because you think of it as, like in your bones, but it's a metal on the periodic table. So we have calcium, which is a +2, chlorine's a -1. So let's look at calcium chloride as far as its solubility. Here's our chloride. It's usually soluble. And look, it's not an exception, so calcium chloride is soluble, which means it will be an electrolyte. All right, I hope this makes sense. Good luck.